You're listening to the Skeptics Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptics Guide to the Universe. Today is Thursday, August 24th, 2023, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santa Maria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, folks.
So, guys, we're a week away from Dragon Con. Came upon us fast this year.
You guys excited?
Yes.
I haven't been in several years because of the pandemic.
It's 4 or 5 years for me.
It's going to be hot and sticky. Welcome to the South.
Yeah, 4 years. It was 2019 last time we were there.
That was our last. Mm-hmm.
Yeah.
I'm expecting intense heat, for sure.
Yeah, for sure.
I don't think since the pandemic I've been to anything this people dense.
Mm-hmm.
And it's been a very long time.
Yeah, I know. I mean, we've been talking about, like, even though we're going and it's et cetera, should we wear masks? And I think if I'm going to be in, I'm not going to wear it all the time, but if I'm going to be in intense crowds, I think I'm going to wear a mask.
I would. I mean, if I'm being honest, I'm not going, of course, but like I would wear a mask. I just got a text yesterday from a new therapist who was supposed to come to one of my sessions with a client for a warm handoff, and he texted me and was like, can't come, just tested positive for COVID. And he had been like in my office the day before. And I was like, no, but it's still happening, you guys.
Every single year that we've gone to Dragon Con, you get the con crud, right? You get,
there's always some kind of
But now the con crud is COVID. That's basically what's going to happen.
Yeah.
Not me.
Don't say that, Bob.
Bob.
Don't say that, man. You could catch it at any time.
Tempting fate.
Yeah, Bob, you got trips and stuff coming
I'll be wearing N95, man. Not
if you do that,
that's... N95.
Yeah, N95 and keep some handy Sandy in your pocket the whole time.
I will not touch a damn thing.
Yeah, it's a good thing you said that, Bob. I got to order some masks.
Yeah, I got too much stuff going on in November. If I miss Disney because of COVID, people will die.
I can't believe we had a whole conversation offline, but like I can't believe you're going to Disney 2 weeks after I go.
I know.
This is very exciting. We'll have to share notes.
Yes.
I told
Steve's daughter and future son-in-law were going to be there when Liz and I are there, so we're going to cross our paths one day.
Wow.
Oh, that's exciting.
Yeah, my daughter just got
Fun.
engaged last weekend.
Yeah.
Wow.
Oh, way. Yeah.
She's so young. I guess that's normal.
Yeah, I know.
I'm like, oh gosh. Oh, wow.
I was anticipating that was going to happen down in Atlanta, but okay.
No.
Oh.
I got I had a vibe. I had a feeling, but I was just off by a week. Okay.
They got
2 weeks.
engaged at a Ren fair.
Yeah.
That's so cute.
Yeah, her fiance is like literally perfect for our family.
Yeah. Yeah, he can stay, this guy.
That's so sweet.
So speaking of Dragon Con, though, I want to make sure everybody knows, if you're going to be there, and if you haven't been to Dragon Con, it's a hoot. You really should consider going. But if you're going to be there, we have a private show on Sunday. Jay, it's 4:30?
Yes.
Yeah, so just go to the website. You can see all the details, buy tickets. It's, our Dragon Con private shows it's a live recording at SGU, and we have time to hang out and have fun. Those are always like the most off-the-hook episodes that we record. They're always a lot of fun.
Yeah, just go to the skepticsguide.org homepage and you'll see a link on there.
Yeah, just go to the events page.
Kara, when do you move home?
So I've got another week technically of work, but I'm not seeing clients. I'm just like doing all the final paperwork. And then I go to Disney. And then I start driving across the country. But I will not go all the way to LA because I've been invited to speak at QED. So I will make it to Texas, visit my folks for a while, and then fly to Manchester and speak at QED and stay in Europe for a few weeks and really enjoy the fruits of the PhD labor. Just take a proper trip. Then I'll come back and make the rest of the trip to LA. So I'm probably actually not going to get back to the West Coast until late October, November. But I'm done here in a couple of weeks. And then I'm just kind of going to go on some adventures. Did I tell you guys what I did? I think I might have already told you this. I wore a hole in my Crocs.
Wow.
Did I tell you this?
No, that's incredible.
Is that even possible?
Wow.
Yes. 1 year of walking a mile to and from work every day wears a hole in your physical hole.
Try walking a mile in her Crocs.
That's amazing.
Wow, that's some good cardio, man.
Pretty symbolic right there.
Did you develop, No blisters? Nothing?
No, not with Crocs. Crocs are the best.
Okay.
I've become a full convert. They're super comfortable.
I wouldn't wear them.
Socks with Crocs? Or
if they were the
socks?
last pair of shoes on the planet, I would not put Crocs on my feet.
I wouldn't wear those wooden clogs they wear.
Crocs are, there's a reason that, like, Steve, you see this in the hospital. There's a reason that healthcare professionals wear them. There's a reason that chefs wear them. They are so comfortable. And for me, being in Florida, where you never know if it's going to pour down rain or be super humid and sticky, like, they're the most brilliant shoes to walk around in. Step in a puddle, the water just flows right out.
Yeah.
And then they're just dry. They're brilliant. And you can put them in sport mode. I might have to get a new pair for Disney.
Wow.
Do you wear those things that people stick in their Crocs?
Oh, the
little badges.
That sounded dirty. Yeah, the little charms. I don't have any charms on my Crocs, but people do it.
You can buy them at the Peter Pan exhibit, and they'll be the TikTok Crocs.
They probably have, like, Disney Crocs. I could probably get
no doubt.
some custom Crocs there for sure.
You should get SGU things to go in those little Croc holes.
Oh, that would be so cute. Little SGU Croc charms.
Now we're doing it.
Oh my God.
You guys. I'm gonna.
If you want them, let us know.
Convince
All right.
you.
Jay, should Japan be releasing radioactive water into the Pacific Ocean?
Huh?
Fukushima.
Well, it's already too late, but
Whoops.
let's talk about this. So Japan began to release roughly 3 Olympic swimming pools worth of treated radioactive water into the Pacific Ocean today, as we record this, August 24th, 2023. The water was from the Fukushima nuclear accident that happened in March of 2011 due to that unbelievably huge tsunami. Most people alive, I'm sure, have seen the video. But if you remember, that tsunami was hugely damaging. It caused up to $300 billion in damage to approximately 2,000 kilometers stretch of the Japanese coast. I mean, it was crazy. If you watch the video of that tsunami coming in and just swallowing homes and pushing everything and destroying everything. And of course, the reactor that was there, you got hit with this and it was overwhelmed. Dumping the radioactive water has stirred up some issues too, right? So we got China is actually very angry at Japan for doing this, and they said that they will not purchase anything from Japan that comes from the ocean. China's customs bureaus said they are, and I'm quoting here, highly concerned about the risk of radioactive contamination brought by Japan's food and agricultural products. And this is bad because this is a significant loss of income for Japan since they export about $600 million US dollars worth of aquatic products to China each year.
That seems like a bullshit political move.
Well, yeah, I mean, I guess it does boil down to the science. So if you're agreeing with what the science says, which of course,
But what I'm saying is, I don't think that China's political decision there is based on the science. I think they're using this as a pretext to do something they wanted to do anyway.
Yeah, maybe you're right.
Yeah.
But that is the biggest market for Japanese exports. It's a big deal. So it's it's not by any stretch of the imagination. $600 million is a huge sum of money. Japan and the International Atomic Energy Agency claim that the release of the contaminated water will be safe, which is nice to hear. So first, why did they choose to dump the water in the ocean anyway? It was like when I first was talking about this with Steve, I'm like, why the hell would they do that? But there's details. So when the tsunami damaged the Fukushima reactors, they needed to flood the reactors to cool them because they immediately went into emergency mode. And the problem was that it took a lot of water to cool off the reactors, and it took a lot of time to do this. And that water, unfortunately, became contaminated with 64 different radioactive isotopes. And in the end, it was 350 million gallons of water that was used to cool the reactors. So it's a large mass of water. But if you think of 3 Olympic-sized swimming pools, visually, it's a lot of water. But it's nothing compared to the volume of the ocean. Just to throw that out there.
But to clarify, the reason why it was so much, because they've been continually cooling those reactors over the last 12 years.
Yeah.
That wasn't just all immediately. That's and they're continuing to develop even further contaminated water. This is an ongoing issue.
Oh, geez.
So right now, they have over 1,000 storage tanks to hold all this water, and they are literally running out of space. And these tanks taking up a huge amount of property that they're in. Japan's like, we got to do something about this. Like we can't just be continuing to fill up these tanks and take up acres of property. So they decided about 2 years ago that they want to dump the water into the ocean. And this is when the process started. This is when all the scientists were getting involved and they were talking to experts and everything. So this wasn't like something that they decided last week and then just did it. It's been in the works for a long time. So from a scientific view, in the past 12 years since the disaster, much of the water has lost its radioactivity simply due to time, but it didn't lose all of its radioactivity. Some of the radioactive materials in the water take a very long time to go away, like thousands or tens of thousands of years. So the water has been treated with several different processes that removed 62 of the 64 remaining radioactive materials, which is very good. We have the technology to do this, and it works, and it's done. These processes are done all the time. It's a known science. The worst thing that remained in the water, unfortunately, was carbon-14 and tritium. And the key factors here is how much radioactivity was in the water that ended up getting dumped into the ocean and that will continue to be dumped into the ocean. So to give you a simple explanation, the levels of carbon-14 are only about 2% of what is considered acceptable to be released into the environment, meaning that there could have been 98% more of this and it would have still been considered acceptable to dump into the ocean. So it was a very, very low amount of carbon-14 going in. And then the tritium levels were well below what is considered safe for drinking water by about a fifth. Right now, according to the scientists, they're saying that these radioactive levels were very low and very safe. And again, like I said, the ocean is absolutely massive. And once the wastewater diffuses into several kilometers of the ocean, the radioactivity will essentially go back to just like all the other ocean water. It won't be any different than any other stretch of ocean water that you test. It's called the background noise of radiation that all ocean water has.
How long would it take to reach that point?
Not long, because they dump the water and then, it will quickly mix with miles and miles or kilometers of ocean water. And, within a very short amount of time, it goes to background noise. It's
background. What's the assessment on immediate potential damage to the ecosystem before there's any, before it spreads out and diffuses?
Well, that's exactly the next point here, Bob. So from a mathematical perspective, everything seems to be fine. But of course, some people are concerned about what impact this would have potentially on living organisms that would come into contact with this. And the first thing I thought of is, will teenage mutant great white sharks come from this event?
Ooh.
Yeah, but it's not a stupid thing.
Teenage.
It's a good concern. We want to know what biological impact will this have. We should be asking questions like this, and we do need to spend money to figure out the answers and get scientists to figure out the answers. And they did some extensive studies, and the idea here is that the radiation could spread throughout the ocean's food chain, which is, of course, we don't want it to do that. Now, in the end, it was concluded that the radioactive water will dilute very quickly in the amount of time that it'll be at certain concentrations, no organisms will be able to absorb enough radiation to cause a negative effect. And even if they did absorb some of the radiation, it'll immediately lessen once they get to cleaner water, or once that that water, the dirty water gets spread around and the radiation's level goes down, their radiation levels will go down as well. So from what the science is saying, the amount of radiation that was in the treated reactor was below safety levels to begin with, and there's nothing to worry about. Once it dilutes with the ocean, it'll be insignificant. And another important thing to note here is that the water is being released over time. So there's not going to be like one giant concentration of it. They'll definitely give it time for it to absorb in and even out, and then they'll do it again.
The only real controversy is, has the bioaccumulation effect been studied long enough, right? So clearly it's going to diffuse within a few kilometers, and it's basically at background levels at that point. Even the current concentration is below safety levels. Again, it's like below the level of drinking water, for tritium. So that's really not controversial. The only real holdout is, we don't know how much living things will bioaccumulate it and then pass it on to the web of life in the ocean. But that's been studied as well, and it seems like it doesn't just keep accumulating. They sort of get to a plateau level, and then it goes away as soon as they get into water that's not contaminated. So it should be insignificant. The other point worth making is that there's, if you take a risk versus benefit assessment, what's the risk of keeping thousands of tanks full of contaminated water, on land? That's probably a greater risk than just letting it diffuse in the ocean.
Seepage, those kinds of things.
Yeah, another tsunami can come along. You just release it all at once.
In this instance too, like this was like a huge natural disaster.
Yeah.
They made mistakes at Fukushima. They definitely made some mistakes. Bad things happen, and we've got to do the best that we can to minimize the impact and everything. And on the whole, getting energy from radiation is it's actually what we need more of. The world needs more energy, and we don't want it to come from fossil fuels. And as bad
it has to be part of that.
Yeah, it has to be in the mix.
Has to be.
And as bad as this is, nobody likes to hear we're dumping radioactive material in the ocean. It's not, it's horrible.
It sounds a lot worse than it is. That's
it certainly
when you actually look at the numbers, it's like, there's a lot of comparisons that you could make to put things into perspective. I always like the banana comparison.
Yeah.
How many bananas is this equal to? Because bananas has potassium in it, and a certain percentage of potassium is radioactive. Or this is a chest X-ray, or this is taking a 6-hour flight. Which is what this level of radiation was compared to. They said, yeah, it's basically the same as taking a flight from New York to Tokyo in terms of the extra radiation that you're going to get. So the thing is, we live in radiation, certain levels of radiation. As long as you get down into that sort of background everyday exposure level where you could measure it in bananas, you just can't worry about that. That's just below the level that you need to worry about.
The dose makes the poison.
Yeah, for sure. Absolutely.
I want bananas to become an official unit of measurement when it comes to radiation.
But I think it's okay and it's natural to not like this. You know what I mean? It's okay to feel like you don't want them to do it.
Well, and I think because how many times have we been told by governments or corporations that it's fine to dump this thing here, and then later we realize it wasn't so fine, And so I think that there is a reasonable skepticism that a lot of people have towards these kinds of conversations.
I think that's another level of why there's protests and everything. It's the lack of trust. It's do we trust?
Yeah, it's a super fun sites. Yeah.
Do we trust the Japanese government and the regulatory agencies in charge of this and the ones doing the testing that their data is accurate and complete? So if you're not going to trust the authorities, then and it sounds really scary. But I think the science here is actually pretty straightforward. Anyway, Kara, tell us about online gaming and mental health. It's maybe a surprising result.
Maybe. It's interesting. If we were to kind of just ask a very loaded question, is playing online games good or bad for your mental health? What do you think would be sort of the standard answer?
It's complicated.
Yeah.
I would say
maybe that's not the standard answer, maybe. But.
I'd think it depends on the individual and it depends on how much time and everything. But in general, the devil's in the details. Are you interacting with and sharing information with people that you don't know?
Mm-hmm.
Well, plus there are other things like, the amount of screen time in a day. You're supposed to be limiting that, and sitting is not good either. So, just the physical activity in itself has some negative aspects to it.
Well, you'll be pleased to know that this study doesn't answer any of those questions. Yeah, actually, the more I dug into the study, the more I was like, So a new study that was published by researchers out of Texas A&M and a couple of other allied universities. Let me see. The lead author, he's an assistant professor of health behavior in the School of Public Health, but they published this in a sociology journal called Sociological Focus. They wanted to look at online gaming and social support and depressive symptomatology. So they did something of a longitudinal analysis, what they call a longitudinal network analysis of individuals, but it's a very small sample. It's 40 individuals, and it's a relatively biased sample as well. That's not to say that most samples aren't. It's all men, but that's the research question, right? It's all men predominantly white men, non-Hispanic white men, who predominantly have either high school diploma or a bachelor's degree, and are single men. So that may be interesting to slice and dice as the researchers continue on with more studies. But basically,
it's basically the mass murder profile.
Oh, great.
That's as I was reading it, I was like, okay, so there's no, this is not a conversation about incel behavior. This is not a conversation where they looked into political views. This is not a conversation about any of that. It literally, what they were concerned about or curious about was these younger men who are spending time playing in a social kind of setting, so we're talking, well, that's not a good way to put it. They're playing video games online where they can speak to other individuals, right? So there's
team engagement.
There's a sort of community, an online community, and they wanted to really understand, how do depressive symptoms here relate to this community, social support, ability to communicate, kind of thing. I would like to see a little more interesting statistical analysis here with mediating and moderating variables. I don't think they did that. But what they wanted to know was, how do some of these things net out? What they found, we have to take with a massive grain of salt, because this is a correlative study. The authors are the first to tell you that, though. This does not tell us anything about cause and effect. It only tells you that individuals who express higher levels of depressive symptomatology are also more likely to go deep with the people that they talk to online about their mental health issues. So this is kind of an interesting thing, right? They found that people who reported more depressive symptomatology were more likely to form and maintain these social ties with other gamers. But there's also a mediating variable there, because they didn't just look at depressive symptomatology, they also looked at real life social support. And that was a really important variable. And so the question here becomes kind of a chicken and an egg question, right? It's very likely going to be both. Is it that young men who are more isolated and more depressed are reaching out via online gaming networks? Or is it that young men who play online games are finding that they're able to have more social support? And so it's kind of a complicated thing. Or is gaming actually inducing some of this depression? We don't know. But the sort of outcome of the research, and the I guess the top line that the researchers want to investigate further and really bring into the discussion, is that online gaming may be a really good thing for these guys who are struggling to find real life social support. Right? Maybe they don't have strong family ties. Maybe that they're not in relationships. Maybe they don't have a lot of friends, and they're finding these friends online that they can talk to about real stuff. And a lot of them did report talking about their mental health, about their mood, about relationship issues, about big decisions, about taking a new job or making a move. So they were finding that, surprisingly, these weren't superficial relationships that they were making. They were doing some kind of interesting semi-structured analysis. So they were asking a lot of questions of these guys, not just, straight survey data. And they found that these guys were really going there with the friends that they were making online. So, the headlines that we're seeing across the board, and this is actually a headline by the lead author, online gaming communities could provide a lifeline for isolated young men. And I think the reasoning here is that we know that depressive symptomatology is on the rise. We know that suicidality is on the rise. And we know that among almost all demographic groups, men are the least likely to seek help. We also know there's an interesting study that I was pointed to through some of the internal citations of this study, that men who score higher on conformity to masculine norms also score higher on measures of stigma toward mental health intervention. So the more they conform to masculine norms, the less likely they are to think that therapy is an option or a valid option, And so we know that it's important, right, for these guys to get help if they are depressed, if they are, contemplating suicide, if they're struggling with really deep issues. Obviously, nobody is saying here that online gaming is a substitute for professional help, but any person who works in mental health will tell you that one of the best predictors of positive outcomes is social support. People need social support. And maybe this is a potential option for them. But I think a lot more research needs to be done into the kind of causality arrow here and whether there even is a causality arrow. Is it just a back and forth?
Yeah, this kind of data is just informing hypothesis generation. It's not answering any questions.
But I do think it's cool that people are studying this.
Yeah.
And I think it's important to study it because I think that we can talk about the extreme examples of like we mentioned before, right? The mass murder profile. Like we can talk about extreme examples of radicalization online, of sort of extreme views being made more extreme by kind of going into an echo chamber. And so if you've got young men who are potentially lonely, but also angry and also feeling very isolated, but like they're owed something more than life is giving them. That's when you might see some of this like deep radicalization. But also, what percentage is that? Is that really just a very small percentage? They just happen to be a worrisome percentage. Is it that the vast majority of young men who are seeking these relationships online are actually benefiting from them greatly? I think that is an important question. And we shouldn't just, as you guys very beautifully showed us at the beginning, paint it all with either a negative or a positive kind of brush. It's complicated.
Yeah, I think there's a couple of things that we could say, not just on this study, but just based on multiple studies. One is that loneliness is on the rise, especially since the pandemic. It really is a social problem that a lot of people
and loneliness is correlated with so many negative outcomes.
Yeah, it is driving a lot of diseases of despair. And it's definitely having a huge impact on our society and our healthcare and our health as a society. So the other thing we could say is that I think online connections are perfectly real, connections. And
I know. I don't even they call it IRL to be funny, I think, in the actual study. They call it IRL, but they use that, let me see, the initialism is in real life. Yeah. So so it's the
online
same. It's the same way we use it.
We're all talking online right now. You know what I mean? It's just an extension of our ability to connect with other people. And so, I think it's kind of almost an artificial separation to think about. Not that there isn't something about the immediacy of being physically present with people. I think,
that's the real question, right? Like we've seen some interesting questions about, is telehealth just as effective, right? Online versus
so far it seems to be by all the research that I've looked at. But I think for... you do get a lot of social interaction online. It may not be 100% of what you can get in person, but it's a lot. And I think that it certainly is a lot better than loneliness.
Yes,
right?
And I that seems to be a big takeaway here. Is that obviously there's a lot of caveats, there's a lot more to study, but like these men are seeking relationships and they're finding them. Right. And the cool thing that this study specifically showed is they're not superficial. They're talking about real stuff and they're going deep with each other and they're getting vulnerable. And I think that is what's key here. That's super important.
And of course, a lot of things can happen in these online relationships. They can't be positive or negative or radicalizing or whatever,
Of course.
It's interesting to think about that. And that's a separate sort of layer to the whole thing. But the relationships are real. They are meaningful. They do sort of meet a need, which is growing in our society, if anything. So it's something we have to think about and look at. Absolutely.
And that's, I think, the core of the question here that is yet to be answered is, are these men who are struggling with depression and isolation going to these places and actively seeking them out? Or is spending so much time gaming online contributing to feeling isolated? Is it affecting their in-person relationships? Is it contributing to their sense of depression? Yeah. And so we really need to tease some of those things out so that we can understand what, the best recommendations are for individuals who have this as a big part of their lifestyle. Should there be limits? Should there be, how much is too much? How much is not enough? I think those are important questions to be asking.
And one other angle to this, which this study did not look at all, which is that for some individuals, they have a lot easier time socializing online than in person. They're almost different people, you know.
Oh, for sure, we know that that's the case for a lot of people who are neurodivergent, for a lot of individuals who are, you know, maybe they are in the LGBTQI community, or they're in some sort of marginalized community, and within their physical community, they can't truly be who they are. And so they find these groups online where they get to actually feel like themselves. I mean, yes, that can be life-saving for so many people.
Absolutely. All right. Thanks, Kara. I want to do a couple of quick ones. These are both in Kara's favorite science, material science.
Material science.
Now, these both caught my eye. So one is about gradient nanostructured steel.
Yeah, baby.
How does that sound? So Bob's excited.
Careful, Bob. Close him down.
As I like to remind everybody whenever we talk about it, steel is still like one of the cutting edge best materials that we have. You know, it's been around for over 2,000 years, and it's still, you know, one of the best materials that we have for a lot of reasons. It's very versatile. There's many different kinds of steel. When we first started developing steel, which is basically just a alloy of carbon and iron, it was pretty primitive. It took a few hundred years of tinkering to really figure out how to heat treat steel, and then it's, you know, over the next 2,000 years we've been tinkering it, and there's basically been two historically important ways that we modify the properties of steel. One is how we heat treat it in terms of annealing, tempering, quenching, and the second is how we alloy it. What other metals do we mix with it? We can give it other properties, make it more springy, make it more rust resistant, make it more heat resistant. You can, you know, give it the properties that you need. But now, in the last 10, 20 years, we've been entering an age of yet a third new type of way to alter the structure and therefore the properties of steel. And that is manipulating the nanostructure of the steel, right?
It's part of the new way.
Yeah, it's all part of the new way. And so that's what this study is looking at. And so what they did, very simply, is they figured out a process where they basically put steel under stress in order to break up large grains of steel into smaller grains of steel. So the grain structure is really what we're talking about when we're talking about the structure of steel. And the heat treat is all about the grain size and the grain structure. But this is sort of another way to do that. And the result of this was essentially you have this gradient of very small grains of steel towards the edge of the steel, and then progressively larger grains, with the largest grains being in the center, right?
It's genius.
Yeah, so it's a pretty smooth gradient, and the difference in grain size is about 100 times. So the big grains in the middle are about 100 times bigger than the smaller grains at the edge. Now, in addition to this gradient of grain size, there's also something they're still studying this, but there's something to do with the interface, like the edges of the grains and how they move along each other. So to oversimplify this a little bit, what this does is, you know, the small grain size makes the steel very hard, while the large grain size makes the steel very strong. And so by doing this, they found a way to increase both the strength and the hardness of the steel at the same time. When normally this is a trade-off, right? You increase one by decreasing the other, and vice versa. If you can find a process that actually increases both at the same time, that's new, right? That is not something that traditional steel technology can do. So let me look at the figures here. So they started with T91 steel, and they turned it into what they call GT91, I guess for gradient T91 steel. So they were able to increase the ductility, which is, you know, basically how stretchy it is. Like how much can you stretch it before it breaks, right? Mm-hmm. It's like taffy. You know, like can you pull it apart? If something that's brittle doesn't stretch at all, it would break right away, right? Something that's very, very ductile, you can stretch it quite a bit before it will break. But this is permanently deforming the metal, right? as opposed to the yield strength, which is how much can you deform it and have it still return to its original shape, right? So like if you have a bar of steel, how far can you bend it and have it still come back to straight without being permanently deformed? That's the yield strength. So they were able to increase both the yield strength and the ductility, even though those two properties usually are a trade-off. And this is significant. I mean, if we're talking about using steel for buildings, for cars, for aerospace or whatever, just the ability to increase both of these two properties simultaneously can have a lot of applications.
Can it be mass-produced at scale?
So they didn't specifically say that, talk about mass production, but there's nothing exotic about the process. I would imagine it can be. And then quickly, the other news item I found, which also can be about steel, but also could be about other types of metal. It's not unique to steel. Do you guys know what kirigami is?
Mm-mm.
Is it like origami?
It's like
folding?
Origami, but it's
Folding.
not.
Is it auto-folding?
No. So kirigami is like origami, but
That's what I said.
But it isn't origami, but it's like origami. But it involves cutting the paper and fitting it together, and folding and fitting it together. So there's the added dimension of cutting it up. It's not one continuous sheet of paper. That's origami.
Ooh.
So MIT engineers were playing around with using kirigami, but with metal, like with sheets of metal, in order to create three-dimensional shapes. Right, so now they're creating basically like these tubes of metal, like tubes of steel, with kirigami techniques. And what they found is that you basically can design the properties of the resulting structure by altering the shape of the kirigami, right? The shape of the holes, as it were, in this like honeycomb-like structure that you end up with. So now we're taking that metal and we're making a three-dimensional structure out of it. That's kind of, it is a little reminiscent of nature, like bones. Bones are similar in that they have an internal honeycomb-like structure. And then that maximizes the strength to weight. At any given weight, it's something that's a lot stronger. So basically, that's what they're doing. But they're using these kirigami basically techniques to do it. And again, the key finding was it gives them a tremendous amount of control, because they could basically decide, do I want to make this more stiff or more strong or more flexible or whatever. They could fine tune the properties at will based upon the three-dimensional shape that they're creating. And again, they said these kinds of structures could be ideal for like making airplanes or automobiles or rocket ships or whatever. It's just a way of maximizing the strength for the weight of the metal that you're using.
How small was the individual pieces? Can you go arbitrarily small and make each subcomponent smaller or larger depending on what you were making? Like you can make a small truss that then you multiply by many hundreds to make a larger structure out of that.
Yeah, I think they didn't really get into like what the range of sizes is, but there's no reason why it couldn't be a very, very long range of size. They were focusing in this study on how can we affect the properties of the end result. Like how can we come up with basically a scheme for having total control over what properties that final structure has.
What if you combine kirigami, though, with that nanostructure?
Right.
Gradient steel. Oh!
Yeah.
Oh, chocolate, meat, peanut butter.
That's called the Psygasm, by the way.
Yeah, so it's basically customizable properties. Right. And now the other thing is you could 3D print these structures. Right, so now we could 3D print, and you could also use 3D
Even
printing.
better.
They're getting better at this. So using 3D printing to control the nanostructure of the steel, and then they can use it to create these kind of kirigami metastructures, right? And so we're just entering basically a new world now. We're taking, after 3,000 years, we now can take this old material, steel, and do all kinds of interesting new things with it, and get even greater properties out of it.
Awesome.
Right. Which, when I was writing about this, I pointed out, it's like, this is important because, there's no such thing as vibranium, right? Like, the thing is, there, like, all of these fictional materials, don't exist. Like, there are no missing elements on the periodic table. There's no unobtainium. Yeah, we're not going to discover some unknown metal that doesn't, or we don't already know about on the periodic table.
Well, what about islands of stability?
Oh, Bob, come on. But that's, stability is a relative term. We're not going to, even at the high end, these are very heavy, unstable elements, and even if there are these islands of relative stability, they're not going to have the properties of a physical.
Well, what if it lasts a
object.
week? For a week, you got a really cool piece of metal for a week.
Then it undergoes radioactive
Sounds very
decay.
useful.
But so we're basically left with the alloys, right? And which there's still a lot to be discovered there, but we've been doing that for thousands of years, and now really just this sort of nanostructured feature of metals, that we'll be able to push this material science to another level, but it's still going to be limited. Yeah. Unless there's something. So it reminded me though of Project Hail Mary. Remember where the
great effing book.
The alien had a material that was made out of, was it xenon?
Yeah,
right?
I think that was it.
It was a noble gas, but they had figured out how to make this noble gas, like make 3 molecules or 3 atoms of the noble gas connect together into this stable, solid molecule. It's pure fantasy, but the point is, he had to make a fantasy material, and this is how he did it. It's like, something like that, where we're making solids out of noble gases or whatever, something ridiculous like that. So you can't rule out that there isn't something like that in the future, using known elements, but combining them in a way that creates some really super high-tech material. But it wouldn't surprise me if there isn't anything like that. You know what I mean? Like that kind of thing is not possible. And you have to wonder, like, in 1,000 years, what are we going to be building our spaceships out of? Maybe it's still going to be steel. You know what I mean? All right, Bob, tell us about supernova and neutrinos.
Sure. Scientists have gained new insight into how the ghostly particles called neutrinos might interact with each other during supernovae. If correct, this could have implications for amazing new physics and new discoveries that I have been waiting many years for. The study is called Toward Powerful Probes of Neutrino Self-Interactions in Supernovae, written by researchers at Ohio State University and published in Physical Review Letters in mid-August. So neutrinos just got even more interesting. Since they are fundamental to this news item, let's have a quick primer. Neutrinos are tiny particles with so little mass that they travel at ultra-relativistic speeds near the edge of the speed of light. They're created by violent nuclear processes like gamma-ray bursts, for example, core collapse supernovas. Our sun and even earthbound nuclear reactors can create neutrinos. There are far more of these little buggers than there are atoms in the universe. There's 500 trillion of them just moved through you as I spoke the first half of the sentence. What? Yes, and half a quadrillion. But that just illustrates why they're essentially like among or the least well-known subatomic particles. They have no charge. They rudely only care about the weak force and gravity. That's it. So they can essentially blithely fly through a regular matter like a light year of lead, for example, without interacting with anything, or a light year of steel, Steve, for that matter. But they may be more friendly with each other than we think. And that potential friendliness, if you will, may lead to new physics. So let's explore that for a second. So why do we think the neutrinos could potentially have this enhanced interaction with each other? It's because these researchers use some astrophysical models that try to go beyond standard physics, the standard model of physics, and they predict that what they call secret interactions between these neutrinos, these enhanced interactions. So those models say that if you get enough neutrinos together with enough density, they could potentially interact far more forcefully together than usual and essentially scatter away from each other in a very distinctive way that this model predicts. Now, these researchers claim that according to at least one neutrino emission model, this neutrino self-interaction could be detectable. And if it is, then that could finally be proof of new physics beyond the standard model and set the stage for a slew of new fundamental discoveries. So their research involved the one supernova that I think all fans of astronomy should be aware of. It's Supernova 1987A. It's A because it's the first supernova of 1987, and of course there was no B. So why is that important? It's because it's the nearest supernova to Earth that was detectable with modern astronomy tools. That's it. We haven't had one since, and it's been many centuries before. It was really a cruel twist of irony. The telescope was invented just after the last detectable supernova occurred in our galaxy in 1604, way back in 1604, and documented by Johannes Kepler himself. Since then, at least statistically, there should have been at least 4, but even up to 12 or even 16 supernovae within our galaxy. And of course, if they did explode within our galaxy, they would have been we would have been able to examine them in exquisite detail, but none have been seen. We see them in distant galaxies all the time, but many millions of light years away is nothing compared to, say, 20 or 30,000 light years, which would be relatively amazingly close and very fruitful to study. So then in 1987, we saw the closest one yet since 1604. It wasn't in our galaxy, but it was in a nearby dwarf satellite galaxy called Large Magellanic Cloud, which we saw a few years ago. Guys, we saw that dwarf galaxy. Yeah, it was magnificent. You have to be in the southern hemisphere to see it, so it's sad that we don't get to see it very often, but it was beautiful. All right, so that explosion was only 168,000 light years away, so astronomers and astronomy enthusiasts were very excited. I remember that day in 87. I was pretty excited. The explosion released the power of 100 million suns, but the heralds of that explosion, like the Silver Surfer perhaps, don't worry about that reference, Kara.
Thank you.
Just ignore that. The heralds of the supernova 1987A were the neutrinos themselves, because they were the first things to get out of that explosion and get to us before any of the actual photons did. So they estimate that that supernova released 10 to the 58 neutrinos. That's a lot of neutrinos. Just that explosion, 10 to the 58 neutrinos were released. We detected 20 of them. So we detected just 20. I don't know how many actually made it to Earth, but it was far more than 20. And it wasn't 10 to the 58, but it was a lot more than 20. But we got 20 of them. We detected them. So if that supernova happened today, we would bring to bear, of course, much more sophisticated technology and understanding than we had back in 1987. We would detect probably thousands of neutrinos instead of 20. And if the supernova were within, well within the Milky Way, we would probably detect many more than even thousands. We would detect a lot of them. But that's the problem, though. To determine if neutrinos follow this new physics, we need to examine a future supernova, one that hasn't happened yet, but it's got to be within our galaxy or a nearby one. That's what has to happen. Betelgeuse, Betelgeuse, Betelgeuse. So what if we do prove it? Well, what if we do prove it? We detect these neutrinos from a supernova, and we determine that there is this extra enhanced interaction between them. What happens? Well, like I said, if that did happen, we'd probably finally start moving toward something that's beyond the standard model of physics and break entirely new ground, and Nobel Prizes would absolutely go around. In the paper, the researchers say the early universe physics could be substantially changed, and that includes the Big Bang itself, of course. Such a discovery could also eventually point to the identity of dark matter and why antimatter is so rare. So many different types of discoveries can happen just because of this neutrino, if this is true. neutrinos are very, very special because they are. Here, I'll give another quote from the paper. They said in the paper, the weakness of neutrinos makes them powerful. Because of their near lack of particle properties, they are sensitive probes of new physics. Because of their high abundance, they are a sensitive probe of cosmology. So they would make an amazing tool just because of these very ghostly and unusual properties. So I'll end with a quote from one of the researchers. He said, "We're always praying for another galactic supernova to happen somewhere and soon." So I would agree, of course. Yes, please, something big and close. Please explode soon. Thank you. I'm done.
Thanks, Bob. All right, Evan, tell us about some recent non-U.S. lunar missions.
Yeah. First, I have a question for you guys. What's the difference between a lunar landing and a lunar crash?
One was planned and one was unplanned.
About 3 days. Well, I'm glad it's, yeah.
One uses litho braking and the other one doesn't.
In any case, Russia and India absolutely in the news this week. Both are players in the world when it comes to space missions. Russia has a vast history of space missions to draw upon, while India is, well, I guess relatively new to the small communities of countries that can consider themselves as off-world explorers. Russia, since the 1950s, when it was part of the Soviet Union, it's been sending satellites into orbit, cosmonauts into space, building space stations, putting telescopes into space, landing craft on the moon, on Venus, and on Mars. And those accomplishments, they're legendary. Let's face it. I mean, hell, they're fixtures as part of the world's 20th century Cold War culture. You can't escape it. But the last time they were on the moon was back in 1976, and that was when the Soviet Union's Luna 24 probe executed a successful landing on the moon. And it collected soil samples, and it drilled into the surface, 2 meters below the surface. Samples were returned. A very successful mission by all rights. But as that French voice from SpongeBob SquarePants would say, 47 years later, in 2023, after all those years, say hello to Russia's latest lunar probe, Luna 25. Makes sense, after 24. And after attempts to engineer this new probe in the late 1990s and again in the early 2010s, Russia finally came up with a design that would survive both the economic realities of the country as well as the having to overcome the technical failings that had crippled prior attempts. So by 2019, they were pretty much ready to go with Luna 25. It came to realizations. With its mission is to spend at least 1 year on the moon before taking off and returning to Earth. Though primarily testing soft landing technology, it would carry a 66-pound payload intended to study soft surface soil, or the regolith, as Bob reminds us. It would examine the atmospheric conditions on the moon and perform all sorts of measuring tasks. And the probe satellites would be generating electricity for the whole mission. So it was very ambitious. 2019, well, it soon became 2020. Of course, that was COVID. And then a few years later, and there were engineering concerns and the country's war against Ukraine in 22. All these things set back the launch of the probe by a full 4 years. So finally, August 10th, just a few weeks ago, 2023, the go was given. Luna 25 was launched on its way to the moon. August 16th, it entered lunar orbit. And on August 19th, the orbiter was given a command to move into a new orbit, which would be ideal for the lander to deploy so it could make a nice, pillow-like soft landing on the moon, with its ultimate destination being a spot near the Boguslawski crater in the moon's largely unexplored South Pole. This would be the first mission to reach the South Pole region of the moon. So, a new first and a historic comeback for Russia to become a leader in space exploration once again. And all they needed was 84 seconds of an engine burn to get to that perfect orbit. So here, count with me. 81 seconds, 82 seconds, 83 seconds, 84 seconds, 85 seconds, wait, 86 seconds, hey, 80 seconds, 7 seconds, oh my gosh, stop. Well, 40 seconds later, the maneuvering engine finally shut off, but too late. And here's the official sentence from Roscosmos, the Russian space agency. They said the apparatus moved into an unpredictable orbit and ceased to exist as a result of a collision with the surface of the moon. That about sums that up in one sentence. And they're forming a commission to investigate the reasons behind why this happened. And, it's really a bummer for them, for their program. They're, very crestfallen over the whole thing, but also it puts into perhaps some jeopardy their partnership with China, among others, for more lunar missions in the future. So that was very much in question. Now, it goes without saying that successfully landing things on the moon is extremely difficult. It takes marvels of technology and ingenuity. It takes feats of engineering and bravery, coupled with great expense, money, and human lives to even make the attempt. Landing something safely on the South Pole region of the moon specifically poses an even higher level of difficulty. It requires, you have to put the spacecraft into a polar orbit at right angles to the moon's orbit. And this requires additional energy to move the spacecraft into this, unnatural orbit is how it's described, which introduces all kinds of uncertainties and critical aspects such as velocity and location of the spacecraft. Plus, you have the added challenge of the relatively rough terrain of the southern pole region of the moon compared to other regions of the moon. There's a reason Apollo 11 in 1969 landed in an area named the Sea of Tranquility, one of the softer spots, surface-wise speaking. Now, achieving a soft landing on the moon's south pole, it's something that no country had achieved yet, but not for lack of trying. 4 years ago, India's Chandrayaan-2 lander crashed attempting the same maneuver as Luna 25 had tried doing. And there have also been probes from Israel back in 2019 and recently Japan just earlier this year. Their missions also crashed. This is not easy. And Russia obviously tried. They were not deterred by the difficulty. And India was also not deterred by this. Yep. India is not the first country I think you think of when talking about space programs, but they are up-and-coming players in space exploration with some recent successes to show for their efforts. Back in 2008, India's first mission to the moon was Chandrayaan-1 program. It launched successfully on October 22 of that year, and it achieved lunar orbit on November 8th. It released a moon impact probe on November 14th, which was a deliberate crash into the moon later that day, so successful. It's best known for finding evidence of water ice on the moon, and NASA made their announcement in 2009 of the research that the data was collected, and it was based on the agency's moon mineralogy mapper. And so that was a very important mission. Now, Chandrayaan-2 was India's second mission to the moon in 2019, and July 22nd of that year, it made it to lunar orbit. On August 19th is when it was launched on July 22, made it into orbit on August 19th. Now, on September 6th of 2019, it released their moon lander, but officials lost contact with it just over a mile above the surface. Oh, gosh. And the lander was not lost, but the lander was lost, but the orbiter, continues to do its scientific research. And it's sending back imagery of the lunar surface, which was important because on July 14th, 2023, just 6 weeks ago, India successfully launched Chandrayaan-3. And yes, just the other day, August 23rd, the lander successfully reached the south pole of the moon, which is great. This mission had 3 objectives. Land safely on the surface. Done. Check that box. To demonstrate rover operations, yes, the rover is moving. It's solar powered, and it is in fact moving. It's already taken pictures. I think the first pictures came back earlier today, if I'm not mistaken. And then there are going to be some scientific experiments performed over the course of 14 days. It's just scheduled to be a 14-day surface mission. They're going to measure thermal properties. They're going to measure seismic activity. They're going to study gas and plasma in the environment on the moon. And they're going to, place laser retroreflectors onto the moon's surface, which, we can always use more reflectors for measuring the moon, among other things. The rover itself carries 2 instruments. It studies the local surface elemental composition, and the orbiter that carried it will study the Earth itself from a lunar orbit. So, big-time congratulations to India achieving a significant first in space exploration. Russia, better luck next time, if there is a next time.
Yeah, it's an achievement. Bravo, brava, everyone.
Yeah.
That was great.
The South Pole is definitely going to be where the action is on the moon. Probably because of the potential of
ice and water
in the deep craters. Yeah. And by the way, Bob, last week you were talking about the Russian space program, and you called that the Soviet Union several times, which is funny because
Yeah.
I edited a couple of them out. It was actually a lot worse than what made it to the show. But,
I don't remember though.
I know, we just at the time, we just went by us. The thing is, we grew up with the Soviet Union, and we are so programmed with that. And I remember when basically when the Soviet Union collapsed, and we had to start referring to it as Russia, referring to Russia as Russia rather than referring to the whole thing as the Soviet Union. It was a hard transition, and it took us a long time to stop doing that, to stop referring, stop saying the Soviet Union when we meant Russia. But it still comes back, even
it still does. And
decades later.
I specifically remember, Steve, correcting myself, switching from Soviet to Russian. I did that once or twice, but some got through that I didn't even realize. Like, wow, okay.
Yeah, it's funny. Okay, Jay, it's Who's That Noisy time.
All right, guys, last week I played this noisy. What the hell is that?
I don't like it.
That's a tough one. At first I thought it was like something scratching to get out of something.
Yeah.
Like in the first part of it. But then the second part has almost this, I don't know, elasticy, rubbery sort of sound to it, like something's pulling on something rubber. But I can't pinpoint
You are
that.
correct. It totally sounds like that. All right, well, before I get to the answers, I have a correction. A couple people wrote in last week. So it turns out I said something wrong about roasting coffee. I said, I think, that they roast it twice, right? Mm-hmm. But that's not correct. They roast coffee once, but there's two different times during the roasting process where basically the bean makes a cracking noise. And in both instances, it's because moisture is leaving the bean. I don't know why. I don't know what I said. I don't remember exactly what I said. I must have said that people were roasting coffee twice. I don't know. Bottom line is,
you said you roasted twice.
I was wrong, and that is the correction. We like to be accurate on this show. All right, so I got an email from someone named Justin Fournier, and Justin said, "Hello, Jay. I'm going to try my hand at Who's That Noisy? Is this the reloading of an old school disposable camera?" And so he's talking about like one of those like paper disposable cameras where you crank it. There's a little thumb crank.
Oh gosh, yeah.
Definitely not a bad guess with those collections of sounds that you hear in this noisy. Not a bad guess, not correct, but I definitely like that guess. Another listener named Edgar Lappins said, "Hi Jay, long-time listener since 2010 and supporter of the SGU. First time Who's That Noisy guesser. Pretty sure I got this one. It's the sound of a very fast change of an inner tube of a bicycle on the side of the road." And there's that rubbery sound, right, Ev?
Yeah, right. What is that?
It's not a bicycle inner tube.
Okay.
Yeah, I'll tell you right out of the gate. It's not rubber. And then the last guess that I'm going to tell you about this week was from a listener named William Steele. And he says, "Hi Jay, my guess for this week would be someone using a grease gun on some heavy equipment and then grease squirts out of the port. Thanks for the great episode." I totally can hear the sound of, you guys, have you ever used like, what do you call that? When you're dispensing silicone or whatever in your home and you have that gun, what do you call it? I forget what those guns are called.
A caulk gun.
A caulking gun. Yeah, that type of thing. So that's what he's talking about. Totally agree that there is that kind of sound going on here, but that's not it. But this was I guess this was really hard because no one even came close to guessing. But that is, if you can believe it, a pufferfish.
What?
What?
That is a pufferfish blowing itself up. So someone caught it, I guess in a net, and they had it like on the boat, and then it just like started to puff itself up. And then when you get to that rubbery sounding squeaky noise, that's when it was getting big. So I'll play it for you real quick again.
Pufferfish.
Right? That's when it's getting really big.
He's gone under the boat.
Crazy.
Wow.
And just so you know, they threw him back in the water, so he's fine.
Good.
Or she.
Unless it got eaten by another fish.
Yeah, and I was disappointed, Kara. You had no idea it was an aquatic animal.
Mm-hmm. But it didn't talk.
Yeah, you're right.
It's when they have those weird human voices. It makes me so uncomfortable.
It's so weird.
I don't like it.
I got a new noisy this week from a listener named Alex Freshy. That's how you pronounce it. I'm dead sure. And here is the sound. Now, we've had 2 weeks of people not guessing correctly, if I'm remembering correctly. We have 2 weeks where no one's guessed. So I'm going to give a hint this week. My hint is that this has something to do with sports.
Okay.
I think this one might be a little difficult. So if you think you know what this week's noisy is, or if you heard something cool, you can email me at wtn@theskepticsguide.org. All right, some announcements for you guys. One, again, to anyone who joined the SGU as a patron, we completely appreciate it. Can't express how much gratitude we have to our Patreon community for supporting us. It's more now than ever. It's really important to the SGU. I did tell you that we haven't been running a lot of ads. Like this week, there's no ads on the show. I've been saying it. You know what I'm about to say. So if you enjoy the show, please consider becoming a patron. It really helps. And it will help us being able to keep moving forward here. You could also give our podcast a rating on whatever podcast player you're using. I think Apple Podcasts has the most impact for us, but either way, if there's any way for you to leave a rating for us, do it, because it'll help new people find the show, which we'd really appreciate that level of support if you just quickly do that. Nauticon happening November 3rd and 4th of November.
Not to be confused with November 3rd and 4th of December. That's a totally different date.
Why would you say that?
Because you said November 3rd and 4th of November.
I did?
I was so confused for a second.
It's like 5 a.m. in the morning.
I just want to make sure people temporarily know where the hell I'm talking about.
What's my PIN number?
Nah.
So we've added some Discord channels that if you are a ticket holder, you would have gotten an email from me by now. We're explaining that, and we have a website. It's notaconcon.com. Okay, don't get confused. We picked it deliberately. We tried to get Nauticon. We wanted Nauticon, but that cost $5,000. So we were like, let's just add another con on there, and that's going to be our domain.
Wait. Nauticon was taken?
Taken and cost $5,000.
Somebody squat on it? I mean,
squat. No, someone's had it.
Since when?
For a while. I think it was like someone's been sitting on that for a while.
So they predicted that we would eventually run Nauticon, and they're trying to future extort us.
But yeah, I mean, just for future reference, if anyone wants to squat on any domain that we might want in the future, we're never going to pay the money. It's never going to happen.
Right.
We don't have any money.
We don't do ransom attacks.
No,
here.
Never. But we were laughing. When Ian and I looked it up, we were totally cracking up. Like, somebody's squatting it. Oh, my God. So we just added con on there.
Crazy.
Ninja Brian will be there. We have an awesome puzzle that's being created, handcrafted for this. It's going to be like a pretty epic, conference level puzzle that'll take the 2 days to solve it, if you can solve it. We have huge number of fun activities. I am also trying to put together a dinner. So this will happen either Friday or Saturday night during our dinner slot. It'll be $49. And essentially, it'll be all of us, everybody that's going to be there doing the conference, running the conference, will do it. So if you're interested, just email us, let us know. I'm very close to pulling the trigger because I did get a lot of responses. It's very likely it's going to happen, but I just thought I'd let you know. So anyway, that's that conference. Now, last thing, let's not forget that we will be at DragonCon the weekend after next. It's coming up quick.
Yeah.
Right? Wait. Actually, Steve, when this comes out, it'll be 1 week, right?
No. It'll be 1 week.
Mm-hmm.
A little bit less. Yeah, it could be. We'll be there on Thursday.
If you're going to be at DragonCon, we will be doing a private show on Sunday at 4:30 p.m. So go to theskepticsguide.org. There's a button on there that'll give you all the details on where it's going to be and everything if you're interested. I think that's it, Steve.
All right. Thanks, Jay. So one email, which is really a bunch of emails, one email topic, as predicted, We had a lot of feedback on our discussion of a study looking at regret and gender-affirming care last week. We pretty much figured we would. It's a very hot-button issue. And the feedback was all, I think, good. It was all over the place in terms of where it was coming from. But when I say good, I mean it was all thoughtful, I thought.
Mostly.
Yeah, I want to address some of the themes of the questions that came up. Because a lot of the people who were questioning our coverage and our conclusion about the study, tended to make the same kinds of comments. I wrote back, I think, to everybody who emailed us on it, or I'm mostly caught up, so most everybody who wrote to us. But I wanted to address some of those points. So first of all, very quickly, to review the study that Kara covered last week, this was a survey of, it's more than that actually. They identified 200 and something patients who were adults. I think the age range was 23 to 33 that underwent top surgery as part of gender affirming care. And then they sent them a survey. They got back responses from about 60%. However, they gathered the information from the chart on everybody.
Yeah.
And which is an important piece of information. And they found that the rate of regret in the survey was basically less than 1%, and none of the people in the study had sought any detransitioning or reversal of their surgery.
And also not just that the rate of regret was low, but the rate of, what did they call it? I can't remember the word that they used, but like how happy they were with the decision they made was very high.
Exactly. Yeah. Right. All right. So one of the questions was, but what about the fact that this was a survey and only 60% of the people responded? Doesn't that make it self-selective? And the answer is yes, that is correct. But it wasn't limited to that. Again, it was basically a retrospective chart review in which you cover 100% of the people sequentially. And then additionally, they had a survey to which they got 60% response rate. So it wasn't just a survey. Now,
right. And none of the people in the chart review had reversals.
Yeah. That's right. Which is not
it's not indicative of a lack of regret.
Yeah, it's not a perfect proxy for lack of regret, but it is the measure that you have when you look at it. So one thing that's, I think, again, a theme in the reply, and also people pointed us to like online discussions of this article, is that this isn't a perfect study. No study of a complex topic like this is going to be perfect. Plus, you're never, ever going to be able to do a placebo-controlled trial of this intervention.
This question.
Or a randomized
of course
trial.
Not. Can you imagine?
You cannot randomize this.
Yeah, you're going to get top surgery. You're not going to get. You can't do that.
Also, by the way, a 60% response rate, I don't think people realize is really high.
That's for a survey. That's not
really good. Yeah, like I think a lot of people don't really realize that. Yeah, like it's hard to get people to respond to surveys.
Yeah, totally.
And usually response rates are super low. 60%. I was like, oh wow, that's great.
Right. But here's the thing, because it's interesting. Like people said, it wasn't a long enough study, or there weren't enough people in the study, or why was it only in this age range? And here's the thing: if you want to do a 20-year follow-up, and you want to do it prospectively, that will take you 20 years.
But they did that in this study. That's the thing that's frustrating.
But they did it. Well, it was retrospective.
It was retrospective, but it had a long follow-up.
Oh yeah, absolutely. It had a 30-year follow-up.
And I think a lot of people were confused, and maybe I wasn't clear enough, but there was a range. They looked at people from 20 plus years ago and people from like 2 years ago.
Yeah, exactly. But what's interesting, but the point I was getting to, Kara, listen to this, is that they're asking for things that cannot simultaneously exist.
Right. Yeah. You can't do a study that answers all those questions at the same time.
Exactly. It's always going to be a trade-off. You can't say, I want a 30-year follow-up of people who are making this decision now. Well, you can't have that. That would take, I'll tell you the answer to that 30 years from now.
Right.
Or 10 years, whatever, however long a follow-up. So, because some people said, well, this was people that they were doing 10 or 20 years ago, and maybe that doesn't reflect the people who are getting the thing now. And other people say, yeah, but we also want a long follow-up. And so, but again, you can't have both of those things at the same time.
And somehow this study actually gave us close to both of those things, yet it's somehow not,
it was a pretty good compromise, and they did the best job they had with the data that they had available to them. And it is what it is, right? Yes, these are limitations of the study. And you're going to do different studies with different trade-offs and add them together to try to triangulate to what is the picture here, what is going on, right? So, so this study was good as far as it went. Yes, it didn't answer every question. Other people said, well, this doesn't answer a question about children. It's like, yeah, you're right. But the point also is that this kind of surgery is only done on either adults or older adolescents. And so one of the other pieces of feedback was that, well, clearly the people in the study had good screening, like they were evaluated very thoroughly, and that's why the regret was low.
No, but all people are evaluated thoroughly for these types of surgeries.
So some people were saying that, okay, well, clearly they were well screened, but this doesn't necessarily apply to the general population where they're not well screened. And I had to ask people, like, why do you think people who seek gender affirming care are not well screened, or that they are not evaluated thoroughly? Because again, there's this persistent misconception, which is deliberate, by the way. This is deliberate misinformation that is being put out there, that it's being done on people who are too young to make this decision. It is being done with too little evaluation.
And sometimes you almost hear them saying that they're being coerced.
That's right. They're being pressured. More than one person. They're being pressured. First of all, no one is pressuring people to get major surgery, right? That doesn't happen.
I also just feel like take a second to take the frame of, let's say we're talking about a child or a young adult who is deeply struggling with their identity. Their local community, there are a lot of people in their local community who are not treating them well, right? They are brushing up against bathroom bills. They are having a very complicated time coming out to the individuals in their family, to their friends. They're getting bullied. And in the best of situations, there are some people in their lives that are supportive of them. And against those odds, they are speaking up and asking for psychotherapy, asking for to speak with a physician who has expertise in this area and say, what are my options so that I can make sure that I'm making decisions that allow me to make my body match what I feel like inside of my head. And then all of those things are being described. Anybody who literally thinks that this is like a drive-through situation, it's like you're not thinking deeply about this.
Yeah,
if anything, the pendulum is on the other side.
I think they're just responding to so much misinformation that's being delivered and put out there.
It's heartbreaking. Because it's really insulting to these individuals, to be honest.
But so here's the thing. There are published standards, and most institutions follow these published standards or more, or like they have their own institutional standards, which are even more rigorous. And that involves not just that you identify as trans or non-binary, but that you have established gender dysphoria over time. Like this is a persistent, established condition that you have. Not just, hey, I want surgery. Okay, sure, come on in, And
also very likely they're doing capacity assessment. They're looking into all of these things.
Yeah, so that's the standard. And so, yes, this absolutely is applicable to the real world because this is what's happening in the real world. This is the standard. So when we said just let the experts deal with it, this is what we mean. They have very rigorous standards that they are generally following. So one other point that was made up, that was brought up was, well, you shouldn't dismiss the 1% of people who do have regret or who detransition. So, and you know what? I don't think we said anything that suggests we are. And in fact, they're important data. The point is, the reason, if anything, I think regret rates are probably getting lower because doctors are doing their job. They're trying to figure out, let's look at that 1%. Let's figure out how we could make it even smaller. What didn't happen for these patients, or what did we not ask? What questions did we not ask? What predictive factors might have been there that we could have looked at? So just like anything, there's a lot of introspection going on among the experts who are treating patients with this, and that's why it's so insulting for some legislator somewhere to say, I know better than these doctors who are like rushing to surgery and forcing or pressuring kids without parental consent. Another one that gets thrown around, which is also not true. These are all not true. These things are not happening.
Insulting to the entire medical establishment that's working really hard. And it's also really insulting to the patients themselves, deeply insulting to the patients themselves. And by the way, one thing that we mentioned last week that you didn't mention just now is that we have some evidence of that 1% of regret. Because remember, this study is not the only study that showed 1% of regret. This is, I think, a more controlled and somewhat more cleanly done study, but it's on the back of a systematic review showing about 1% of regret.
Yeah. And not only that, I actually did some more, research into what's been published recently since that systematic review. There was another systematic review that was published. 27 studies, 7,928 transgender patients who underwent some type of gender-affirming surgery, and again, the regret rate is 1%.
Right. And among those who regret it, the vast majority of them, not all, but the vast majority of that 1%, which we apparently ignored when we talked about this last week, which we didn't because I know we mentioned this. Yeah. The regret, they were able to point to the regret being stigma. Mm-hmm. It's that after they underwent gender affirming surgery, they were experiencing stigma for having their outsides match how they felt insides. There were people in their lives that were shaming and blaming them for
that's
that.
like at least like a good half or something.
Yeah.
So that still leaves some people who have legitimate regret because they changed their identity or whatever. The results weren't what they thought it was going to be.
Exactly. Or they had pain after the surgery or the pain, the risk-benefit analysis didn't work. And that's what we have to remember too. We're still talking about a major surgery. Yeah, so we can't just assume that regret meant, all of a sudden now I want to detransition. I'm actually not trans. Oopsie daisy. It could also mean maybe my version of being non-binary, maybe my identity with breasts was actually more important to my identity than I thought. And now that I've lost them, I'm feeling regret about that. That has nothing to do with this narrative of people going, whoopsie doodles, I changed my mind.
Right, because I was socially pressured into it.
Right, because they're not making a capricious decision. And I think that's the important takeaway here. None of this is taken lightly. And the narrative that is taken lightly is divorced from reality, and it's also deeply insulting to the data, the science, the practitioners, and the patients themselves, and their families, by the way.
Mm-hmm. No, I agree with that. So the bottom line is, because so some people said, well, you're extrapolating too much from this one study. And I said, well, we did point to a previous systematic review with thousands of patients and many studies. And the thing is, there's a very consistent signal here in the data. No one study is ever going to be perfect. Again, this is all going to have to be ecological data, epidemiological data, observational data, retrospective, whatever, because you can't do a controlled study here.
Yeah.
You have to put all these different pieces together. And when you do that, it's pretty consistent that the regret rate is extremely low for a surgical intervention because the process is pretty much, thoughtful, ethical, and responsible. And I asked some of the people who wrote, so I said, why are you especially concerned about this? Why is this type of I think it's because there are political movements out there that are trying to make you agitated and upset about this.
Right.
But again, not to minimize legitimate concerns. With any surgical intervention, there's legitimate concerns, absolutely.
Yeah, but what are they?
But the thing is, this is lower by about an order of magnitude than pretty much the average of other surgical interventions. Mm-hmm. You know what I mean? If you look at some that are, I think, that are close to the line in terms of elective surgeries that have really high rates of regret. You compared this to just cosmetic surgery, for example. Why would you be all up in arms about this when it's an order of magnitude better than other things?
And also really thinking about the language here, the politicized language. We use the word gender affirming in this situation to affirm a trans or non-binary gender. But there are gender affirming, cisgender affirming surgeries that people do all the time. People get cosmetic surgery all the time to affirm their masculinity or their femininity in a cis way. And the regret rate amongst those surgeries, as you just mentioned, is significantly higher. And somehow socially, we're just much more accepting of that. And I think that's an important important question to ask yourself. Why is that? Why are we so much more accepting of that?
So just check your assumptions. Again, so the email's like, people are being pressured. Why do you say that? There's no evidence that people are being pressured into this, or whatever, or that this is being done on minors. Well, hold on. Or that there is this like social contagion. Like, wait a minute, where are you getting that information? Because none of these things are true. But this is the narrative that's being thrown out there.
And I think sometimes it seems like a reasonable conclusion to jump to people when they say, well, this didn't happen before and now it's happening now in larger numbers, so it must be a social contagion, as opposed to, or we're recognizing this as an important part of care.
Yeah.
This is more often
it's been happening
affirmed.
for a long time.
It's been happening for a very long time.
Demand,
like a very, very long time.
Demand is increasing because, yes, we've raised the social stigma to some extent. And
right, because people are allowed to be who they want to be. Who they really are.
Right.
Like, and so of course, and we're seeing that the medical profession has done their due diligence and they're researching this and they're seeing, okay, there's something to these arguments that these individuals are identifying this way. And who am I to tell you who you are? You're the person who tells me who you are.
Right. All right. I'm sure we'll get more feedback on this.
Oh,
that's
sure.
okay. It is again. We're most interested in how do we properly interpret the science, but the science here is pretty strong, and so it's a good lesson in how to sort through sort of the political noise and try to look at the actual evidence.
Yep. Check your bias at the door.
Check your bias at the door, but also I think it is important that we understand that, and this is coming from, I'm going to say it, I'm going to pull the card, like something of an expert in this field, that these political biases, these conversations that we have about the actual evidence, the science, still happens on the back of the construct itself. And so sometimes when you hear me be passionate about identity or about the individual being the empowered person to claim a certain identity, that is also science-based. That is coming from an understanding of human psychology, and it's coming from an understanding of what the label transgender or gender fluid or non-binary actually means. And I think sometimes we have these political conversations where we assume that everybody is agreeing on the definitions of a lot of terms, when I don't think they always are.
Yeah, that's a good point.
So, yeah, okay.
All right, let's go on with science or fiction.
It's time for Science or Fiction.
Each week, I come up with 3 science news items or facts, 2 real, 1 fake, and then I challenge my panel of skeptics to tell me which one is the fake. We have a theme this week, and that theme is protein, or proteins.
Protein?
Proteins.
Oh, that's different.
Yeah. Okay, here we go. Item number 1. Hero proteins in humans are heat-resistant, long-lived proteins that have no direct function themselves, but help keep other proteins from clumping and causing cell aging. Item number 2. The longest known protein in vertebrates is called titin, which can be 350,000 amino acids long. And item number 3. The median half-life of human proteins is 8.7 hours. Jay, go first.
So you got these hero proteins, which I've never heard of before.
Have you heard of villain proteins?
And they're called hero proteins because they're heat resistant and they're heat resistant and they're long lived, and they help keep other proteins from clumping and causing cell aging. I don't know. That sounds too good to be true. That's my first red flag. The second one, the longest known protein in vertebrates, is called titin. Steve,
Titin,
which can be 350,000 amino acids long. And then the last one, this is the other one I wasn't so sure about. So why would the half-life of a protein, okay, I heard you wrong. The half-life of a protein is 8.7 hours. So what would that mean that it's the average lifespan is?
like 2 days or something.
Yeah. I mean, would they come and go that quick? Would there be any reason why they would? I mean, that just doesn't seem right that a protein would come and go that quick. So it's between the hero protein, which I've never heard of before. He put it in quotes, which means that he didn't make it up. And it's the half-life one. I'm definitely going between one of those two. I'm going to say that the half-life one is the fiction. Don't think that they are that short-lived.
Okay, Evan.
Well, I thought of the three, I was probably felt most assured, and we're talking a low level here of assurance because I am protein deficient when it comes to this information. Half-life of the human proteins, plural, is 8.7 hours. So we're talking about all the proteins, types of proteins there are in the human body. So, we're talking about a median half-life, meaning, half or more, half or less. So I think based on those calculations, I don't know how many different human proteins are there. Am I allowed to ask that? There's a lot, probably. So therefore,
proteome.
8.7 hours. Therefore, I think that calculation could wind up being correct. The other two, absolutely no clue. You're spelling Titan Titin. That's not a typo, is that, Steve? Or that's how it's?
No, it's not a typo.
It's pronounced Titan, not Titan. Titan. Okay, well, whatever. I mean, it's just a guess at this point for me between these two because I really don't have anything to base this on. So basically, if you're saying in these hero proteins, if we didn't have them, we'd experience like death at age 15 or something, maybe, right? it would significantly cut down our lifespan.
You're reading into it.
Yeah, I don't know how to interpret this one. So I don't know. I'll just say the longest known protein. Usually it's the shortest ones are correct in a sense, but fine. I'll just say it. Longest known protein. That one's fiction, and I don't know why.
Okay, Bob.
All right. So the hero protein and the median half-life don't seem overly shocking to me. The second one, though, 350,000 amino acids long, seems way too many amino acids. I'll say that's fiction.
And Kara.
Yeah, I like the hero protein thing. Heat resistant, probably something with an O because that's such a common way. We love to name like proteins and...
it's we now, is it?
No, really, like the entire scientific community.
Soon to be Dr. Kara.
Wow, this took long. Did not take long.
We as human beings.
Come
also,
on,
by the way,
it's an easy one. I had to go for it.
Hero proteins, it's so common, I feel like, with especially protein names that they have these, like Sonic Hedgehog and things like that. Titan, it's probably also like an initialism. So they're heat resistant. That makes sense. No direct function themselves, but help keep other proteins from clumping and causing cell aging. Well, wouldn't that be their direct function?
Yeah.
Yeah, what is that? I don't get what that means. They have no direct function themselves. Their function is to protect other proteins.
Other than
no
that.
function other than to.
Yeah,
but all proteins have very specific functions within the cells.
So basically, you can think of it. They don't have a specific function other than helping other proteins do their job. Basically,
right? They're almost like it sounds to me like they're almost like the opposite of a catalyst. Like they're preventing denaturation, which we would need that. Of course, that probably exists, especially in organisms that are in high heat. I have no idea what the half-life of a protein would be at all.
Yeah, that one was.
But I know that we're constantly making them. Like it's just a constant churning factory. So I wouldn't be surprised if we're like, remaking proteins over and over, like all day, every day. It does seem more reasonable than the one that two guys have already said. 350,000 amino acids. I mean, I guess it's possible, but that seems really long. Like maybe this is a thing where they discovered it after a really long time because nobody wanted to keep going when they were coding it. And it just took them a long time. But this one feels too long to me. So I think I'm going to go with Titan also being the fiction.
Okay, so you guys all agree on the hero protein. So we'll start there. Hero proteins in humans are heat-resistant, long-lived proteins that have no direct function themselves, but help keep other proteins from clumping and causing cell aging. You guys all think this one is science, and this one is science.
Yay! I know, I got nervous.
Yeah, that pause.
I didn't.
Unnecessary tension there.
Very necessary.
So what's interesting is that the hero proteins were not named as the English definition of the word hero. This was a Japanese discovery, and
it's a name.
So the original name of the proteins were hero kun, Kun. So it came from the informal Japanese word meaning weak or not rigid, and a diminutive suffix normally attached to a young boy's name. But then when the function of the proteins were discovered, then the term hero took on another meaning.
Yeah, right.
So it was just fortuitous, I guess. Now, what recent research has found is that these proteins actually extend the lifespan of cells, and in fact, when they engineered these fruit flies to make more of these proteins, they extended their lifespan by 30%.
Let's do it to people. Come on.
So they also were found to protect lab-grown human motor neurons.
Oh wow, that's a big deal. It's a really big deal.
So this is a potential research pathway to look to see if we could both treat neurodegenerative diseases, a lot of which involve at some point the buildup of clumps of old proteins, right? But also maybe just generic life extension. Who knows? So it's one more thing, to do. So we know that proteins clumping up and gunking up the works is a bad thing. It's related to degeneration and aging, and there are mechanisms to fight against that, and this is one of them. And maybe this now opens up the possibility of, maybe we could give a boost to these hero proteins. Although, we always have to be cautious because, there's a reason why we're not already flush with these things. You have to wonder, why don't we just have a lot of them already in our cells? And, what's the homeostasis here? What are we interfering with? And what would be the potential downside? Yeah. But who knows? It may just be that there's some headroom here to optimize this. Okay, let's go on with number 2. The longest known protein in vertebrates is called titin, which can be 350,000 amino acids long. Everyone but Jay thinks this one is the fiction, and this one is the fiction.
Yeah,
guys.
Too long?
When I was doing research on protein folding, I remember specifically that the longest ones are in the thousands, the low thousands, not a third of a million.
So titin is the longest protein that we know about. How big do you think it is?
1 order of magnitude less.
Yeah, 35,000.
up to 35,000.
That's still enormous.
That's still a lot.
It's still enormous.
Is it in humans?
Yep.
Wow.
It is in humans. It is. Guess what tissue would you think it's in?
The
skin?
Penis.
Stomach.
It's in muscles. It's the
muscle.
third most common protein in muscles.
Really?
Okay.
Yeah.
Interesting.
After actin and myosin.
And myosin, yeah.
Yeah, the big boys.
Cool. The big boys, yeah.
Right. Okay, which
Titan.
means that the median half-life of human proteins is 8.7 hours, is science. That is a surprising number, Jay. That's why I put it in there.
Yeah, it feels low, but then you think
really
about it and you're
low.
like, yeah, maybe.
And because we do underestimate the degree to which we are constantly overturning our structures, And I remember being surprised at this at some point in my medical training when I realized, really, these proteins turn over every 2 days? That's how the cell goes through all the trouble of making this channel or whatever, and then it's dead in 2 days, and they got to recycle it and make another one and replace it. It's like a constant turnover of proteins.
ATP, baby.
But it's also not, I think we also have this tendency because we think in terms of we think holistically, the bridge is torn down and then the bridge is rebuilt and then but it's pieces of it are always being made.
Yeah.
It's it's replacing, it's kind of like our blood cells or whatever, they're replacing themselves, but not all at once, It's
it's a constant stream.
Yeah.
That's right. And also, this is the median, as Evan was pointing out. There are long-lived proteins, like the hero proteins, right? There are long-lived proteins. But here's the thing. Interestingly, they're the problem because the long-lived proteins are the ones that tend to clump up and cause problems. And so which points to, this is why there's an advantage to having short half-life proteins that are constantly turning over. They do not clump up and clutter everything because they're constantly being overturned. As opposed to ones proteins like some structural proteins where they last for years. They're very, very stable. But those are the ones that generally, like if there's a protein that's building up and causing problems, it's a long-lived protein. It's not one of these short half-life proteins. But yeah, so it's like one of those facts that's kind of surprising when you first learn about it, but that it makes sense, once you realize how cells function. All right, so good job, guys. Evan, give us a quote.
A funny one. I think a funny one this week. America is the only country where a significant proportion of the population believes that professional wrestling is real, but the moon landing was faked. David Letterman.
Oh, wow.
Yeah.
Gosh. I loved David Letterman. His show was, his late night show was great.
Yeah, it was.
So much fun. All those top 10 lists, I could watch those forever.
All right.
He is still with us. You can still love him.
Yeah.
Yes, that's right. And he has a show where? Where is it? Netflix? Is it
YouTube?
He does an interview, like a one-on-one
My next
interview
guest
show.
is, or something like that.
Yeah, but as far as late night shows, that was probably the one I watched with any level of regularity.
He definitely broke new ground in the late night talk show kind of genre,
Definitely.
I saw him at a gas station once.
Did you? Proud of you.
Did he use 87 or 89?
He was a diesel
Didn't get
man.
that close. give him his room.
All right. Well, thank you all for joining me this week.
Sure, man.
Thanks,
Steve.
Steve.
And until next week, this is your Skeptic's Guide to the Universe. Skeptics Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.